Is my screen visible? Visible. My voice is audible, right? Okay. So I think not many students are joining today. So, anyways, I'll start. So because we are recording, so they can see it later also. So last week I was not able to. I mean, this week I was not able to take the class as I was unwell. So as a compensatory class, I'm taking it today, and I'll just discuss a few problems, and we'll call it a session. So let's just look into this first problem. So we have these m random samples from a Bernoulli distribution with parameters p, and it is asked which of the following is an unbiased estimator of p into 1 minus p. So, so it is. So if you look at the option, it is given in terms of x bar. X bar is the sample mean. Equal to 1 to m. And we know that the sum of Bernoulli variables, if I call it y, this has a binomial distribution with parameters m and p, and we want to find the unbiased estimator of this p into 1 minus p. So we have these options, so we can maybe just, so for the unbiased, for it to be an unbiased estimator, if t is the unbiased estimator, then expected, if t theta is the unbiased estimator of theta, then expected value of t theta should be equal to theta. So let's just see. I take these and let's just try to find out. So if you look at it, we'll have an x bar square term also when this and this multiply. So we know expected value of x bar, that will be 1 by time m times the expected value of y, which is equal to mp, right? The expected value of a binomial random variable, and there is 1 by m times that. So this is p. And expected value of x bar square it should also come in this. So for that, we know that variance of y is equal to mp into 1 minus p, which is expected value of y square minus expected value of y square. So this is basically expected value of uh, like m times this. What I want is expected value of x bar. So what I get is p1 minus p plus m square, and this is what, p square divided by m square. So this is this. Oh, sorry, this should be. Now you can just substitute and see in each of these things. M1 will cancel out.
Sir, E of x bar is p, so E of x bar whole square will be p square, right? So mp into 1 minus p plus p square is
Sorry, what did you say?
E of x bar whole square is p square, right? Because E of x bar is p.
Huh.
So it has to be mp into 1 minus p plus p square, right?
There is this m square also, no?
Uh, okay, okay,
So I took this here and I
okay, okay.
divided by that square. Okay, just check if everything is
I
correct.
mean, like E of mx bar, that would be like fine, but E of x bar is what we are supposed to take, right? So, because variance of x bar we are taking into consideration.
E of x bar is p,
Yeah,
and e of x bar square is this, right?
yeah, variance of x bar plus E of x bar whole square.
Sorry, what did you say?
E of x bar square is equal to variance of x bar
Yeah, yeah.
plus E of x bar whole square, right?
Yes, sir. I mean, yes, sir. Yeah, so we just started from variance of y, and because we know the variance of this binomial.
Okay.
So if you are able to follow this now, like from variance of y, which is equal to this yi substituted with the x bar term.
Yes, sir. Yes, sir.
Yeah. Okay. So we can, like, if we do expectation of the thing, first option, what we'll get is, can take the m into m minus 1 outside, expectation of x bar plus x bar square. So which is m into m upon m minus 1 into expectation of x plus expectation of x bar square. So this we know is p, and this is this p into 1 minus p plus mp square upon m. So what do we get? Get mp plus mp square plus p minus p square, and this m and m will get cancelled. We have p plus p square, p minus p square. So we won't basically get p into 1 minus p from this. But if instead we had taken, let's say, this other term, x bar into 1 minus x bar, expectation of x bar into 1 minus x bar, so then what will happen? What will happen is we will have p minus p1 minus p because it will be expectation of x bar minus expectation of x bar square. So this plus will become minus here. Then we have mp uh, minus p plus p square plus mp square by m. Now if I take m common, I get p and here will be minus, right? p minus p square minus p. So this is equal to m minus 1 into p into 1 minus p by m. So expectation of this is giving us this. So if this we multiplied by m into m this term, m divided by m minus 1. I'll just extend this page. So if I do and that is p into 1 minus p. So this is the unbiased estimator, and we can take the expectation outside and this will be the answer. Is it clear? So we just took expectation over the options that were given. So we just checked for we just had to check for like x into 1 plus x bar and x into 1 minus x bar, x bar into 1 minus x bar, because they are the only two variants, and this constant term we can like just check if by multiplying that we are able to get p into 1 minus p or not. So when we did x bar into 1 plus x bar, we got something like this, and from this we are not able to get a form of p into 1 minus p common, because there is p plus p square here and here there is p minus p square. But when we take expectation over this, we are able to get this p into 1 minus p common outside. So if it's clear, can I move to the next question? Okay. So we have these n random samples from a population with this density function, and we are asked to find the maximum likelihood estimator. So we have this exponential like distribution, and so to find the maximum likelihood estimator, we'll find the joint distribution of n random samples given theta. That will be the product of f of x given theta. So that will be theta power n e power minus summation theta xi minus 1. So we can take log of this. What we will get is n ln theta minus this will be n times, because the answers are in terms of x bar. Summation I xi will be n x bar. So now we can take the derivative of this. And equate it to 0. Again 1 by theta is equal to x bar. Oh, there is theta here also. So there is an n here. So we can say the maximum likelihood estimator of theta is 1 by x bar minus 1 from this. Is it clear? Okay. So I'll go to the next question. So here we have been asked the unbiased estimator of theta, and we have x which are randomly sampled from an exponential distribution. And it is in terms of x bar. So what will be the distribution of x bar? X bar is so y is n x bar, that is sum of exponential random and exponential random variables. Then that has a gamma distribution, right? Parameter n comma theta. So we know that the expected value of gamma distribution, which is alpha by beta. When it is gamma alpha beta, it is alpha by beta. So it will be n by theta. But this is not what we want. Right? This gives us an unbiased estimator of 1 by theta. We want an unbiased estimator of theta. So if we see in our this is n times c. So if we see in this, we can see there is 1 by x bar everywhere. So let's just find the expectation of 1 by y. So can someone tell me the PDF of gamma distribution?
Um, theta power n.
Okay, so f of y is equal to theta power n.
Yeah, theta power n. Y power n minus 1.
Y power n minus 1.
E power minus lambda y.
Power n minus lambda.
Yeah, lambda y.
What is lambda?
The arrival rate.
So it will be theta in
Yeah,
our case, no?
it will be theta. Sorry. Yeah,
Yeah.
right. Divided by gamma n.
Gamma n. Okay. Cool. So if we substitute this, what do we have? Theta power n, y power n. So this y can be taken out from here. And so we can adjust these terms such that if I take one theta outside, and this gamma n can be written as n into gamma of n minus 1 into gamma of n minus 1, and here it is theta of, I'll write this separate, theta of n minus 1 upon gamma n minus 1 y power n minus 2 e power minus theta y dy. Okay, so what I did is this y I multiplied with this term, so we got n power y power n minus 2, and 1 theta I took outside, and this gamma n I rewrote as n minus 1 into gamma n minus 1. So if you look at this term, this is a gamma distribution with n minus 1 comma theta parameters. So this is with n and theta, gamma n theta. This is gamma n minus 1 theta. If you compare, this is gamma n theta. So this doesn't have any y term. So the integral of this part will become 1. So what you have is theta upon n minus 1. So then you can say expected value of n minus 1 by y is equal to theta, which is equal to expectation of n minus 1 by n x bar. So we have this n minus 1 by n x bar. Is it fine? Okay. So we now we are given n random samples from this normal distribution, and we are asked to find the maximum likelihood estimator. So we know the procedure. We'll write which is what will come out to be
Sir, it will be root theta, right?
yeah. Thanks. So log of it's some kind of a quadratic here, I guess. You should take the derivative first. This I can write as minus n by 2. So if I take in derivative, what I'll get? That should have been half.
Sir, in e power minus sigma I to n, I think the denominator 2 theta should come.
Ah, yeah.
It first limited minus n by 2 theta.
Hmm. Here, na? So this 2 will get cancelled.
No, sir, first term minus n by 2 theta.
Where? Oh, here.
Yes, sir. Yes, sir.
Here also, it should have been 2, no? I had missed that part. Wait. Yeah, so that 2 will get cancelled here. And here, what you will have is this will be xi plus theta minus. Just check this part if I made some mistake.
Why root theta comes in the bottom while differentiating?
This one.
Yeah.
So if you take theta inside this, you will get root theta, no? Inside the square term. So I just took root theta
Oh,
inside the square term
okay.
and then I differentiate.
Oh, okay.
So 1 by root theta derivative will be minus 1 by 2 into divided by
And
theta root theta.
we can just apply the quotient rule of differentiation, right?
Yeah, that also you can. So we have a given that summation xi square by n we can take as w. So then what do you get? So this summation xi square will be n w minus n theta square divided by. So we have like a quadratic. So the roots of this. I think it isn't something in terms of like this. No?
So this is not understand how these two terms came,
This one,
this term.
the root of a quadratic equation, minus b plus minus root of b square minus 4ac.
Okay, okay, okay.
Okay. So one of these values, like both of these values, will make it go to 0, but we want the one which maximizes this function. So at maximum, uh, what do you want? Your double derivative should be, so theta is either 1 plus, at maxima your double derivative should be negative. So that means this quadratic should be positive. So the double derivative of this quadratic will be what? Like if you take the double derivative, that will come out to be something minus times 2 theta plus 1. So for positive theta, your double derivative will be negative. So you will get positive theta for this term, right? This will be negative. This will be positive. I think this should have a minus 1 now. So here it is minus 1. Still this term will be positive because minus half plus this is under root 1 plus 4w will be greater than 1. So this term will be positive. So then this should be the answer. Which one? This one.
Sir, how the conclusion came from the double derivative? Please explain once.
So we just checked for this quadratic part.
Yeah.
Uh, what we want is the maxima. So for the maxima we want the double derivative to be at maxima. The double derivative should be negative, right?
Yes.
So we have minus times this thing.
Uh,
So we will want the double derivative of inside part to be positive.
then minus 1. Okay.
So if we substitute this theta, we'll get positive, right?
Huh. Huh.
So if it's clear, should I move to the next question? There is some more doubt.
No, sir. Move to next question.
Okay. So it is asked. We have been given n random samples from normal population with mean mu and sigma square. Which among the following is not a consistent estimator for sigma square? So can someone help me to recall the what do you mean by consistent estimator? If you have some set of estimators T1, Tn, or something like that. We have an estimator in terms of n, na? In terms of n random samples. expectation of Tn tends to theta and then
Variance tends to 0.
as n tends to infinity, theta n should tend to theta and variance of theta n should tend to 0. Is that correct? Just like this. Variance of Tn should tend to 0. So what is S square? S square is summation xi upon n minus 1, right?
Yes.
So we know like expectation of S square is equal to sigma square because it is an unbiased estimator of sigma square. So for all n it is anyway equal to sigma square.
But is this normal distribution?
Normal.
Okay, okay.
And what is the variance of S square? You have any idea?
Sir, n minus 1 into a square by sigma square is follows the chi-square n minus 1 distribution.
Yeah.
So variance of a square is n minus 1 by sigma square.
Should be sigma square by n minus 1, right?
Sorry, sigma square by n minus 1.
Okay. So here if it n tends to infinity, this variance is tending to 0, right? As n is going to infinity for S square. So you can say like this is a consistent estimator. We have been asked what is not. This is consistent. For this term, if you see it is what this will also be as n tends to infinity. This term will tend to 1, right? This will tend to 1 and this will tend to sigma square. For this term also, as n tends to infinity, it will tend to 1. This will tend to sigma square. But for this term, this will go to 0 as n tends to infinity. So this is not a consistent. Is it clear? Okay.
Sir,
Yeah.
sir, there is a theorem
Hmm.
stated that if expectation of Tn equals to theta n
Hmm.
tends to theta, and Btn is equals to sigma square n tends to 0, then Tn is the consistent estimator of theta.
Hmm.
This came from Chebyshev inequality equation. How this is came, I cannot understand the last step in the uh, probability of Tn mod of Tn minus theta n greater than greater than eta minus mod of theta n minus theta.
Sorry. Can you explain again? What?
Uh, there is a theorem
Huh.
that if e of Tn equals to theta n
Hmm.
tends, tends to infinity,
And tends to.
tends to theta,
Huh.
and Btn equals to sigma n square tends to 0 as n tends to infinity.
Huh. Huh.
Then Tn is consistent for theta.
Yeah. That is what we used na in the previous question.
Huh?
Yeah.
The SAT proved this.
Huh. Huh.
Prove this theorem. There is SAT use the probability term where the Tn minus theta n mod of Tn minus theta n greater than eta minus the mod of theta n minus theta
Mod of Tn minus theta n.
greater than theta minus greater than it greater than eta minus mod of theta n minus theta.
Okay, you mean like this. This.
Yes. Then in the last step, sir says that sigma n square by eta minus theta n by theta whole square.
Okay, this step you understood, no?
This step is understood, but from this step, how come sigma n square by theta the eta minus mod of theta n minus theta whole square.
How it came, you are saying.
Yes.
So you wanted by definition you want to prove this, no?
Huh.
And we get an upper bound using the above thing. This is greater So this you can write. And from this, how you got what you asked sigma n? That is what you're asking, no?
Yeah, sigma square by eta minus mod of theta n by theta whole square.
I think that is where Chebyshev inequality is used. Is Chebyshev inequality discussed?
Discuss was the
Can
I
you tell?
don't remember.
Huh?
I don't remember the term.
Can you just Google? So this is it. Probability of x minus mu greater than k sigma square is less than equal to 1 by k square.
Acha.
So this is your random variable. This is the mean.
Hmm.
So here we have similar terms, no?
Acha. Acha. Acha.
This k
Hmm.
will come in terms of your
Eta.
this epsilon minus theta and minus theta.
Eta.
X is your random variable, mu is the mean.
In. So it is sigma square by. Okay, sir. Understand.
Sir, in the previous problem, I have a doubt.
Mhm.
Variance of s square, how is it sigma square by n minus 1?
So this has chi-square distribution, right? Chi-square
Yeah.
n minus 1. So the variance of that random variable.
Okay, it has a chi-square distribution with, okay, n minus 1 degrees of freedom. Okay.
So we'll just solve this one last question. So we are given x1, x2 are two independent random variables, and xi has, sorry, normal distribution with mean. B1, B2, sigma and sigma are non-positive constants and mu is a non-parameter. So we are asked to determine the maximum likelihood estimate of mu based on x1 and x2. So I think it is very much similar to what we have been doing before.
Sir, I'm sorry, still there is a doubt on
Yeah,
that
sure, sure.
variance.
This question.
Yes, sir, the
Hmm.
previous one. Actually, the variance of chi-square distribution with n degrees of freedom is 2n, right? Sorry, yeah, with n degrees of freedom, it's 2n, right? So it has to be 2 into n minus 1 in this case, right?
Sorry, sorry.
S square is a chi-square n minus 1 variable, right?
Hmm.
So variance of s square has to be 2 into n minus 1, right?
Is it?
Yeah, because variance of chi-square distribution with n degrees of freedom is 2n. So
Let's check.
yeah.
Yes, sir. This is true.
Oh yeah, it's 2k, no?
Yes, sir. 2k. 2 into n minus 1.
Hmm. Yeah, you're right then.
And one more thing, if a square is like, if n minus 1 into s square by sigma square is actually following chi-square n minus 1 distribution. So does it also mean s square is also following the same distribution?
Sorry, sorry.
N minus 1 into s square by sigma square is actually following chi-square n minus 1 distribution. So does it also mean that s square is also following the same distribution?
Oh yeah, 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 you're right. This follows the chi-square distribution, no?
Yeah, n minus 1 into s square by sigma square.
Yeah, this follows chi-square distribution. Correct, correct. So n minus 1. This follows chi-square distribution, right?
Yes.
So then variance of this random variable is n minus 1. 2n minus 1, you
2
said.
into n minus. Yeah.
Okay, so what is the variance of constant times a random variable?
Can we take n minus 1 to the denominator of sigma square, like s square by sigma square by n minus 1, so that
Sorry, I didn't get you.
can we take n minus 1 to the denominator of sigma square?
Like this.
Yeah.
Hmm.
So,
So variance of S square is what? Expected value of, one second,
divided by n minus 1 whole square.
one second. My is my screen visible?
Uh, yeah.
Okay, I think my network had some problem.
Okay.
Yeah, what are you saying?
Variance of s square is equal to 2 into n minus 1 divided by
2 into n minus 1 divided by,
sigma power 4 divided by n minus 1 whole square.
like this.
Yeah.
I think it should come out to something like this, from what I recall. This will give some trouble.
Sorry. I think it has to be the reverse, like into sigma power 4 by n minus 1 square. Reciprocal of the denominator.
N minus 1 power 4 into sigma square.
Sorry, n minus 1 square on top, sigma power 4. On the bottom, it is n minus 1 whole square.
Can you repeat?
2 into n minus 1, as usual. Then divided by n minus 1 whole square on the numerator, sigma power 4.
Like this.
Yeah.
Should be sigma square or sigma power 4?
Uh, it has to be sigma power 4 because we are actually uh, squaring the constant, right? So, in case of variance,
Variance is sigma square, no? All
yes,
the random variables.
yeah. And since we have the constant sigma square by n minus 1, we have to square it when it comes to the right hand side, right?
Oh, okay, but here I think it is n minus 1 by sigma. Oh no, it's sigma square only, no?
Right, yeah.
Okay, you did it like that.
Yeah.
Once explain how sigma to the power 4 comes.
But taking the square of this term.
Say like variance of x by a if we take, so it will be like 1 by a square into variance of x, right, Abhishek?
Ye- Yes.
Yeah, so when we are actually finding variance of x, it will be a square into variance of x by a, right?
What did you say when you are finding variance of?
When we are finding variance of x by a,
Hmm.
it will be 1 by a square into variance of x, right?
1 by a square into variance of x.
Yeah.
This is variance of x square, sigma square by a square.
So their a square term here is like sigma square divided by n minus 1. So when you are taking a square of that sigma square by n minus 1, it will be sigma power 4 by n minus 1 whole square.
Sigma square is a constant term.
Correct.
Okay.
So for these terms, here as n tends to infinity, variance will go to 0. So this may be correct.
Yes, sir.
Uh, so again, the last option is what stands, is it? Which is wrong.
Yeah, here it will. Here the expectation of this term itself is going to 0 as it.
Yes, yes, yes. Okay.
So I'll go to the question.
Okay, sir.
Yeah. So here what did we have? We had this term. And we can take the derivative. So this will go. This term will go to 0 because it is to mu. No? So here it's mu.
Sir, it ln term, ln of fx term, second term should be minus na, minus of summation I equals to 1 to 2.
Oh yeah, thanks. So yeah, so the minus here will go. Okay. There are no options here, so you can just assume this is the answer. So any other doubt you want to ask? So in the coming Tuesday we will have the session for week 10. Week 10, this was week 9. No?
Sir, one question. Like in the previous question, there was one more option, right? Can you just show that option?
This one.
Oh, yes, sir. N plus 1 by n a square. Okay, sir. Thank you.
Sir, I have a doubt that at assignment number 9,
Mhm.
in question number 8 and 10.
Assignment 9, question number 8. One
Yes.
second. This one.
Yes. This one do this.
Mhm.
Uh, uh, e to the power summation I is equals to 1 to 6 xi minus theta. Take ln take ln in L, minus summation I is equals to 1 to 6 xi minus theta, Then del L by del theta is equals to minus 1 is minus I is equals to 1 to 6 xi minus theta into minus 1, it is equating to 0. Then summation I is equals to 1 to 6 xi is equals to n theta. N here is 6 to so 6 theta. So theta is equals to 1 by 6 summation I is equals to 1 by 6 into xi, and there is giving the 6 data points. So the MLE of theta is theta cap is 1 by 6 of 6 data point. I get I do that way. This is okay or not?
What you are saying is whatever we are doing, like consider each of these samples and you are computing the joint distribution like that only, no?
Huh? Actually, you are doing in the previous last two examples. You are doing L calculating L by pi is equals to 1 to n fx. So I do this way,
So you are not getting the right answer.
not getting the right answer.
Okay, let's try.
Sir, one point.
Uh,
Actually, what I felt in this question is that when I got the answer wrong, but what I felt is they are using the definition to get the answer. They are not using the calculation method because x is greater than theta, right? So the parameter
hmm.
space itself will change.
Yeah, 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 yeah. Hmm.
I don't understand what he is saying. What he is saying.
So here, if you look at the distribution, this distribution is defined as this for x greater than theta.
Huh. It's greater than theta. Yes.
So it is different for like you want the theta which is like the lowest one. So if you take any,
Explain in copy now, please.
huh?
Sir, please explain in copy. Explain in a page. I
Yeah, yeah,
don't
yeah, I
understand.
understand. Please.
Sir, can I try to explain and what I understood?
Yeah, yeah, sure.
Okay.
Yeah, please.
Theta is actually greater than, lesser than x, right?
Huh?
So we want to evaluate the parameter space first. So according to the definition, so what parameter space we can define is like if you have theta lesser than minus 2 in the first case, then we have like the space to be minus 2 to minus infinity to minus 2, right? Theta
Yes.
can take any value from minus infinity to minus 2, just like that we have like up to minus 9. So what we have is minus theta to minus 9 is the maximum I mean, this is the only possible thing which we can get in such a way that you know uh, uh, x can be greater than all the parameters, like minus infinity to minus 9 is the only possible interval where you can have any value of x being greater than theta, right?
I don't understand what you are saying.
uh,
So if you
like
look,
In the number line, you consider a number line and take 0 to 0 to infinity line, and here 0 to minus 2,
Minus infinity to
uh,
infinity. Ah.
sorry, minus infinity to 2,
Ah.
it will be defined.
Yes, minus infinity to minus 2 will be the first case. In the
Yes.
second interval case, it will be minus infinity to minus 6, minus infinity to 5, and so on, right?
Okay, 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 okay.
So minus infinity to minus 9 is the only possible thing, so that all other values will be greater than that. So parameter space minus infinity to minus 9 means obviously minus 9 is the one which is having the maximum value there. This MLE has to be minus 9 is what I have thought it should be the answer.
Okay.
So here if you see, you have minus 2, some minus 6, minus 5, minus 9, and then 5, and then 9, right? So this e power minus x function, it will, depending on what theta you choose, e power x minus x function is something like this, right? E power minus x. So if I choose theta equal to minus 2, let's say theta equal to minus 2, so that means this distribution is only defined for x greater than minus 2. For everything else it will be 0.
Right.
So it is something like this, the distribution function, and everything is 0. So if everything is 0, then that distribution cannot generate these samples, no? Only if the distribution is of this kind, it will generate all these samples.
Now this is the maximum point.
So yeah, if you go beyond like behind this,
Hmm.
then the probability of all the samples for for this particular theta, for theta less than minus 9, the probability of all of these minus 9, minus 6, minus 5, everything decreases, right? By this much.
Yes. Yes.
By this much it decreased. But if you take something greater than minus 9, then minus 9 cannot be generated by that distribution. Understood? If theta is greater than minus 9, then minus 9 won't be generated by that distribution, because the probability of minus 9 for that distribution will be 0.
Yes. Yes.
So at minus 9 you get maximum for all. So that's why the
Okay.
answer is minus 9.
Okay.
Okay, sir.
Okay. I want to say that if I follow this method, when it is true,
What are you saying?
I want to say
Mhm.
the methodological way, the L, first L come, then
So
DL
you will
by
have to
D.
verify, like, is that a global maximum point or not?
What happens is f of theta will be like 0 for every case. Then obviously dl, I mean ln of that function will not exist, right?
Yeah.
Yeah, that is also there.
And 10, sir.
10th
Question number
question.
10.
x1 xn be random sample from uniform 1 comma theta population where theta greater than 1. If xn equal to max, then which of the following is an unbiased estimator of theta?
Sir, here I do the PDF of Xn by the follow of order statistics.
Mm-hmm.
N factorial by n minus 1 factorial into fx is 1 by theta minus 1 into CDF. CDF is x minus 1 by theta minus 1 whole to the power n minus 1. The term comes that n into x minus 1 in 1 to the power n minus 1 divided by theta minus 1 to the power n.
Do you have like screenshot or something? I'm not able to follow.
Screenshot. No, sir.
So okay, I'll write it. What is the paste this question? So your answer is not matching.
Answer it not matching, sir.
So you got a different unbiased estimator,
Yes, sir.
where others also not able to match their answers. Yeah, what are you saying?
I am saying the PDF of xn
Hmm.
maximum term PDF of xn or follow the order statistics.
Uh-huh.
So there is n factorial divided by n minus 1 factorial
N factorial divided by n minus 1 factorial.
into fx. Fx is 1 by 1 by theta minus 1
Hmm.
into CDF of n minus 1. CDF is x minus 1 divided by theta minus 1 whole to the power n minus 1
X minus 1.
divided by theta minus 1
Hmm.
whole to the power 1 minus 1 whole to the power n minus 1.
This whole.
Yes. And term coming n into the x minus 1 to the power uh, sorry n into x minus 1 to the power n minus 1 divided by theta minus 1 to the power n.
Hmm.
Then for the unbiased estimator case we estimate the value from integration 1 to theta x fx.
Why did you do that?
Right.
You integrated this.
Yes, yes.
Why did you do this?
Expectation of
Expectation of x, sorry, expectation of theta. Unbiased estimate of theta means expectation of theta means xn.
expectation of x n, right? The thought
Xn.
the
Xn.
Hmm. Okay.
Then this integration come to the n theta by n plus 1 plus n plus 1 plus 1 by n plus 1
And theta by n plus 1 plus 1.
plus 1 by n plus 1. So theta is the maximum point. So n by n plus 1 into xn plus 1 by n plus 1. This does not match in this with any option.
Uh, but one tip what I thought was like though they have given xn, what I thought was we could take up the x bar itself, like expectation of x bar, and then we could try the easiest of all the options, and then we can move on to the rest if that doesn't work. So I tried from the C itself first.
Instead of xn, you took x bar.
Expectation of x bar. So that will be theta plus 1 by 2.
Expectation of x bar is theta plus 1 by 2.
Yes.
Okay.
Yes, yes, it is theta plus 1 by 2.
So you got this.
Yeah. So I just started from the easiest and then I went on to see. Yeah. If this since this worked out, I just put up this option.
Yeah, this is correct, no?
Yeah. Yeah.
And this option was not matching, no?
No, sir.
Yeah. So you can because x bar is also there, so you need to check for that also, no? For
Yes,
x
sir.
and the options are not matching, but you can check for x bar and this.
Okay.
Yeah, this also may be correct only,
Okay.
but there can be many unbiased estimators for the same parameter.
Okay.
Okay, sir.
So it's good that you are trying all these things. Any other doubts?
Sir, I have a one doubt, small doubt,
Hmm.
that in case of interval estimation,
Hmm.
if the data is given, if the 10 data points is given,
Hmm.
uh, when I calculate the variance,
Hmm.
I will calculate the sample variance or the uh, population variance.
I didn't get your point.
Uh,
When you're computing the variance
there is a
for
10 data points.
uh,
Okay, there is a 10 data points. First we calculate the mean,
uh,
and then we calculate the variance. To calculate the variance, which I consider for sample variance or population variance, means 1 by summation of xi minus x bar whole square divided by n minus 1, or summation of xi minus x bar divided by n.
yeah, yeah, I understood what you're saying. So, but for what are you calculating this variance?
You would not discuss you discuss this next to next class, I think. This is assignment 10 question regarding.
Acha,
You
acha.
cannot discuss. I you not allowed to discuss this. So I just take it point of that.
Okay, okay, okay.
I want to just know about the point, getting the point to the I solve the problem, but no answer is matching. So I thought this.
So when you have some a number of samples and then you're computing the variance, then you take the sample variance.
Okay, okay, means n minus one.
Huh.
Okay,
But if you are doing it over a random variable, then it by default is the variance over that distribution. No?
They are said the uh, they are said that two columns follow independent random distribution.
Hmm. So what is covered in this like week 10 is interval estimation.
Week 10 is interval estimation.
Okay.
Interval estimation, UMBUE, and Kramer-Rao Blackwell estimator. Sir, there are any question about least square moments of sorry, least square method of moment, this said discussed, but no example is done in there.
Least square error.
Least square error, yes. Least square error method, no example is done.
Okay.
Yeah,
Yeah, I also
how it
forgot
is
about
works.
that. So have you studied this thing called linear regression?
Yes, linear regression studied.
Yeah, I think it is a kind of the same principle.
Okay. Uh,
You
the estimator, how it is where it is applicable. The estimator,
Mhm.
where it is applicable. The
So you are finding the value of
cap,
uh,
alpha cap and beta cap,
uh
where it is estimate, why this estimator are sx SSE by n minus 2 is the sum unbiased estimator of theta sigma square.
sorry.
SSE, error sum of square
Uh,
divided expectation of error sum of square divided by n minus 2 is the unbiased estimator for sigma square. Said just like this, and no maths is doing, no mathematical application is not there. Can you suggestion that where the mathematical application is where the mathematical application is there?
the mathematical application for that unbiased estimator.
Yes.
So in real life,
Not in real life, not
uh,
in the yeah, I thought in the exam, if the least square method is coming, so if the least square method, the unbiased estimator is coming,
uh,
so how to tackle this problem we cannot understand. So I said that
so you want some
in
questions.
it's questions regarding this. Yes.
You can maybe refer to this Sheldon Ross book. In that, you might find some questions.
Okay, Sheldon Ross.
Uh,
Okay.
or one more book is there, D. Groot.
हाँ आप बोल रहे थे डीप रूट हाँ. ओके.
Okay. So I'll end today's session and we'll meet next week on Tuesday.
Okay, sir.
Yeah. Bye.